السلام عليكم ورحمة الله وبركاته. Inshallah, we'll start in Unit 3, Chapter 2. That's the chapter in this curriculum, which talk about acid and bases. First lesson talk about acid and base theory, okay, or properties of acids and bases. Acids are used in medicines, making medicine, okay, explosives, flammable materials. Some of them are acids. Car batteries. Inside the car batteries, there is acid like sulfuric acid. Okay. Plastics in making plastic, fertilizers. Okay. Also, the base is used in medicine, making soap. Soap is made from sodium hydroxide. detergent اللي هي المواد المطهرة أو المنظفات. Dyes that used in coloring clothes. This is the uses of bases. Orange, lemon, and tomatoes contain citric and ascorbic acids. Dairy products contain lactic acids. Dairy products like yogurt, cheese, milk contain lactic acids. Soft drinks contains carbonic and phosphoric acids. While bases, the soap containing sodium hydroxide NaOH, baking soda contains sodium bicarbonate, washing soda contains hydrated sodium carbonate. Okay, this is the acids and bases in some of our products that we use it. Properties of acids and bases. What is the acid? Acid is a compound which has sour taste, like the taste of lemon, and it turns the color of litmus paper into red. Change blue litmus paper into red. It reacts with metal forming hydrogen. For example, magnesium is a metal which reacts with hydrochloric acid HCl. Okay, هيدينا magnesium chloride. Magnesium more active than الهيدروجين هيعمل له replacement. هيديني حاجة اسمها magnesium chloride MgCl2 plus الهيدروجين gas evolves. يبقى هنا ايه اللي بيحصل؟ ان طبعا لازم نعمل balancing. هنا Cl2 نحط هنا 2 عشان الإيكويشن تبقى balanced. يبقى الأسيد react with metals forming hydrogen. Acids react with carbonate or bicarbonate salt forming carbon dioxide gas. Okay. It reacts with alkalis or bases forming salts and water. What are the differences between bases and alkalis? Bases, some of them dissolve in water and the other don't dissolve in water. Bases that dissolve in water called alkalis. Okay. Right. What is the base? Base is a compound which has bitter taste and soapy feel, which turn the color of litmus paper into blue. Okay. Bases react with acids forming salt and water. What are the properties of acid and bases or acid and bases theory? We have three theories explains the definition of acids and bases. First theory called Arrhenius theory. Okay, Arrhenius theory. Arrhenius defined acids as the substance which dissociates in water producing one or more positive hydrogen ion, like HCl substance, HCl aqueous, when it dissolves in water producing positive hydrogen ion. Okay, so it is called Arrhenius acid. يبقى any substance dissolved in water producing positive hydrogen ion called what? Called Arrhenius acid. For example, another example لو قلنا H2SO. Arrhenius base substance which dissociates in water producing one or more negative hydroxide ion. For example, NaOH. Okay, when it dissolves in water تديني حاجة اسمها OH negative aqueous hydrogen ion, hydroxide ion. Okay, so it is considered Arrhenius base. In this theory, acids which contains positive hydrogen ion, or when it dissolves in water give positive hydrogen ion, while base containing negative hydroxide ion. Okay? This theory helps to explain neutralization reaction of acid and bases forming salt and water. This figure, okay, figure A, considered as an acid. Why? Because it contains positive hydrogen ion when it dissolves in water. Figure B, base, because it contains negative hydroxide ion when it dissolves in water. Figure C, neither acid nor base, because it doesn't contain neither positive hydrogen ion nor negative hydroxide ion, so it is neutral or salt. What are the defects of Arrhenius theory? Carbon dioxide. Carbon dioxide doesn't contain positive hydrogen ion. Okay, according to Arrhenius, it doesn't considered as an acid. But it's found that when carbon dioxide dissolves in water, it forms carbonic acid, H2CO3 carbonic acid. Okay, so it is considered as an acid, but in Arrhenius point of view, it doesn't contain positive hydrogen ion. طالما doesn't contain positive hydrogen, so it doesn't considered as an acid. Okay. Also, ammonia doesn't contain a source of positive hydrogen ion, but when ammonia gas dissolves in water, NH3 dissolves in water, it gives ammonium hydroxide NH4 OH, which is a base. Okay, so the two defects of Arrhenius theory: it doesn't consider carbon dioxide as an acid because it doesn't contain positive hydrogen ion. Also, it doesn't consider ammonia as a base because it doesn't contain negative hydroxide ion. Classify the following substance into Arrhenius acid or Arrhenius base. احنا قلنا Arrhenius acid must contain a positive hydrogen ion. طيب هنيجي نشوف HNO3 when it dissolves in water هيدينا ايه؟ لو عملنا له dissolving in water هيدينا H positive plus NO3 negative. هنا aqueous هنا aqueous. Okay, طالما contains positive hydrogen ion, so it is considered as Arrhenius acid. طيب calcium hydroxide when it dissolves in water H2O, okay, هنا Ca positive 2 plus 2OH negative. هنا برضو عندنا ايه؟ negative hydroxide ion, one or more negative hydroxide ion, so it is called Arrhenius base. يبقى Arrhenius acid must contain one or more positive hydrogen ion، عشان كده بيقولوا عليه positive hydrogen ion producers. Arrhenius base must contain negative hydroxide ion، أو بنقول عليه negative hydroxide ion producers. Okay. Second theory, which is Bronsted-Lowry theory. Bronsted-Lowry theory, the two scientists make a theory to define acid and base. Bronsted-Lowry acid defined as it is the substance which gives up proton or proton donor، هو اللي بيتبرع بالH positive. اللي بيتبرع بالH positive بقول عليه ايه؟ بقول عليه Bronsted-Lowry acid. Okay. Bronsted-Lowry base substance that accepts proton بتقال عليه proton acceptor، هو ده اللي بيستقبل البروتون الH positive. هنعرف ازاي دلوقتي. فلو قلنا HA ده symbol of acid for example، مين هنا؟ ال A ده ال positive hydrogen ion or البروتون، و B هنا base. طيب the substance which give proton called proton donor, so it is called an acid. Substance which accept البروتون called base. يبقى اللي اتبرع بالهيدروجين هنقول عليه acid، اللي accept الهيدروجين هنقول عليه base. طيب الاسيد بعد ما بيحصل له donation، بعد ما بيتبرع الهيدروجين هيبقى اسمه ايه؟ هيبقى اسمه conjugate base. طيب البيز بعد ما بيأكسبت الهيدروجين، بعد ما خد الهيدروجين هيبقى اسمه conjugate acid. دي في البرودكت، يبقى الكونجيجيت بيز والكونجيجيت اسيد دول موجودين في البرودكت، لكن الاسيد والبيز دول موجودين في الرياكتنتس according مين give proton ومين accept proton. تمام. طب هنشوف example. عندنا H2O بقت OH. يعني ايه بقت OH؟ يعني الهيدروجين قل، يعني في هنا H راحت من الووتر للأمونيا. اوكي، الأمونيا بدل ما هي NH3 بقت NH4. يبقى مين اللي اتبرع بالهيدروجين؟ الووتر. يبقى الووتر considered pronosted lowry acid لأن هو gives proton. مين accept البروتون؟ NH3 لأنها بقت NH4 في البرودكت. ده معناه إن الأمونيا هي اللي accept البروتون، فبنتقال عليها pronosted lowry base. اوكي. طيب الأسيد بعد ما حصل له donation، بعد ما اتبرع بالبروتون بقى اسمه conjugate base. اوكي. والبيز اللي هي الأمونيا بعد ما accept البروتون هيبقى اسمها conjugate acid. اوكي. Example. Try to think which one is an acid, which one is a base, what is the conjugate acid, and what is the conjugate base. Try to think. عندنا CH3COOH بقى ايه؟ بقى CH3COO. يبقى مين هنا البروتون دونر؟ ده اللي اتبرع بالبروتون، الاسيتيك اسيد. CH3COOH ده بنقول عليه اسيتيك اسيد. ده البروتون دونر. بروتون دونر هو اللي اتبرع. طالما هو اللي اتبرع يبقى هيتقال عليه ايه؟ هيتقال عليه اسيد. مين اللي accept البروتون؟ الووتر، ال H2O، لان ال H2O becomes H3O، يبقى هي اللي accept البروتون، يبقى الووتر هي بيز. طيب الاسيد when it donate proton هيبقى اسمه ايه؟ هيبقى اسمه conjugate base، والبيز هيبقى اسمها conjugate acid. تمام. فلو بصينا كده هنقول ان ال CH3COOH ده acid. okay because it donates أو give a proton. البيز اللي هي ال H2O لأنها accept البروتون. الأسيد اتحول ل conjugate base، والبيز changes into conjugate acid. okay. هنشوف فيديو كده explain Arrhenius theory و pronosted lowry theory.
The Arrhenius theory of acids and bases defines an acid as a substance that releases protons in solution, and a base as a substance that releases hydroxide ions in solution. We know that ammonia can act as a base and exhibits alkaline properties, but contains no hydroxide ions. How is this possible? In this lesson, we will learn about the Bronsted-Lowry theory of acids and bases, which fills in the gaps in the Arrhenius theory. You have learned that acids are substances with a pH lower than 7. We can test for acids using universal indicator solution, or paper, which turns red or orange, all depending on the strength of the acid. Blue litmus paper also turns red in the presence of an acid. An example of an acid that you are likely familiar with is hydrochloric acid. Hydrogen chloride dissolves in water to give hydrochloric acid. Hydrogen chloride will dissociate to give a proton and a chloride ion. The proton is not just released, but it is transferred to another substance. For our example, water accepts the proton to form a hydronium ion. A hydronium ion is also known as an oxonium ion. A Bronsted-Lowry acid is a substance that releases or donates protons in solution, in our case, hydrogen chloride. A Bronsted-Lowry base is a substance that accepts protons in solutions, in our case, water. Notice that the definition of a Bronsted-Lowry acid or base is not a function of pH. So an acid-base reaction, according to the Bronsted-Lowry theory, involves the transfer of a proton from one substance to another. In the introduction, we mentioned that ammonia acts as a base even though it does not release hydroxide ions, which is stipulated in the Arrhenius theory. When ammonia dissolves in water, it accepts a proton from water. Notice that this reaction also involves a proton transfer. Can you figure out which substance is acting as an acid in this example? Which is acting as a base? Please pause the lesson to think about this and resume when you are ready. In this example, water acts as a Bronsted-Lowry acid because it releases a proton. Ammonia acts as a Bronsted-Lowry base because it accepts a proton. So a base, according to the Bronsted-Lowry theory, does not need to have a pH greater than 7, or turn red litmus paper blue, or turn universal indicator solution or paper blue or purple. The only requirement is that it is able to accept protons. Have you noticed that water acted as a base in our first example, but as an acid in the second example? Substances that can act as either an acid or a base are amphoteric. In conclusion, according to the Bronsted-Lowry theory, an acid is a substance that dissociates to release or donate protons. A Bronsted-Lowry base is a substance that accepts protons. Therefore, an acid-base reaction, according to this theory, involves the transfer of a proton. We learned about the Bronsted-Lowry theory of acids and bases. We will now learn about conjugate acids and bases using our knowledge of the Bronsted-Lowry theory. Let's do a quick warm-up. Vinegar is a 5% aqueous solution of acetic acid. Vinegar is used in cooking worldwide and is sometimes used as a cleaning agent. From the equation, which describes the behavior of acetic acid in water, could you identify the Bronsted-Lowry acid and the Bronsted-Lowry base? Pause and resume when ready. The Bronsted-Lowry acid is acetic acid because it releases a proton. Water accepted a proton from acetic acid, so it is a Bronsted-Lowry base. As we have learned, an acid-base reaction, all according to the Bronsted-Lowry theory, involves the transfer of a proton. Let's now look at what has been formed from this reaction. The acetate ion is formed when acetic acid released a proton. The acetate ion is the conjugate base in this reaction. Can you remember what this is called? Pause and resume when ready. This is a hydronium ion, also known as an oxonium ion. The hydronium ion is formed when water accepted a proton from acetic acid. This is the conjugate acid in this reaction. When a Bronsted-Lowry acid releases a proton, the resulting species is its conjugate base. When a Bronsted-Lowry base accepts a proton, the resulting species is its conjugate acid. Acetic acid and the acetate ion is a conjugate pair. Can you identify the other conjugate pair in this reaction? Pause and resume when ready. Water and the hydronium ion is the other conjugate pair. So an acid and its conjugate base is a conjugate pair, and a base and its conjugate acid is also a conjugate pair. Now, are you ready for a challenge? For this reaction, try to identify the Bronsted-Lowry acid, the Bronsted-Lowry base, the conjugate acid, and the conjugate pairs. Let's grab a piece of paper and a pencil, pause the lesson, and resume when ready. The Bronsted-Lowry acid is sulfuric acid as it releases a proton to ammonia. Since ammonia accepted the proton, it is the Bronsted-Lowry base. The hydrogen sulfate ion is the conjugate base of sulfuric acid. The ammonium ion is the conjugate acid of ammonia. Therefore, sulfuric acid and the hydrogen sulfate ion form a conjugate pair, and ammonia and the ammonium ion form another conjugate pair. In summary, a conjugate base is formed when a Bronsted-Lowry acid releases its proton. and a conjugate acid is formed when a Bronsted-Lowry base accepts a proton. A Bronsted-Lowry acid and its conjugate base is a conjugate pair, as is a Bronsted-Lowry base and its conjugate acid.
Third theory is Lewis theory. Lewis theory defines an acid and base according to electron pairs acceptor or electron pairs donor. Okay? Acid is the substance that accepts an electron pair or more, while base is the substance that donates an electron pair or more. For example, okay, if we have A considered as a Lewis acid because it accepts electrons from B. Okay, so it is electron pair acceptor, so it's considered as acid. While B gives electrons to A, so it is the electron donor هي اللي اتبرعت بالالكترون فبنقول عليها Lewis base. Okay, فيحصل bond between the positive ion and the negative ion, okay, forming bond, kind of covalent bond between A and B. For example, and then NH3, nitrogen has lone pair of electrons, okay, so it donates electrons for the positive hydrogen ion, gives electrons to positive hydrogen ion. The positive hydrogen ion accept the electrons from ammonia molecule. Okay, so it is electron acceptor. When it is accepted electron, it's called Lewis acid because it accepts electrons from ammonia. Ammonia donates electrons to H positive اللي هو الهيدروجين ion، فالأمونيا considered as a Lewis base وبيعمل لي في الآخر أمونيوم اللي هو NH4. okay. يبقى Lewis define الأسيد as electron pair acceptor and base electron pair donor. ماشي. This is a summary. Arrhenius classified acid according when it dissolves in water it gives positive hydrogen ion. Okay, يعني it must contain source of positive hydrogen ion. Base must contains negative hydroxide ion. Bronsted-Lowry said that in الأسيد is a proton donor هو اللي بيتبرع بالبروتون. البase proton acceptor. Okay. Lewis, the acid which accept electrons, okay, electron pair, while in case of base donates lone pair of electrons. This is the summary for theories which explains the definition of acids and base. أتمنى يكون الموضوع واضح بالنسبة لكم إن شاء الله، ونبدأ هنحل عليه قريب إن شاء الله. شكرا.